Okay, FRQ4, last one. There are so many different things I can put on here, so I put a whole bunch of little notes for you all to go through with you. So first is the properties of logarithms. So more than likely you'll have to use one or maybe all of these properties of logarithms. So if you have two logarithms that are separated by addition, what do you use to bring them together? Multiplication. So this is the same as log of A times B. All right, what about subtraction? What do you use to bring them together? Division. What if there's a number multiplied in the front? What do you do with that number? A to the B. Good. It moves up to an exponent. Good. Okay, it's very possible that you might have to solve a logarithmic equation. And so if you have log equals a log, what do you do to solve it? Do you want to drop off the logs? What about log equals a number? You loop it. So some people call it the loop. Some people call it write in exponential form. Whoops, spell it right. All right, if you're solving an exponential equation, it's good, if you can, to write them with the same base. And I think we'll do one of those. Maybe not, but I know you have one to practice where you write them with the same base, and then once they have the same base, you can just set the exponents equal to each other. If you can't write them with the same base, you're going to write in logarithmic form, which is the other version of the loop. All right, and then you're probably going to have to use a trigonometric identity. So I have most of them on here. I took off the sum identities because I don't think it's going to be on the FRQ. It's probably going to be on the free response. So anyway, take a second, see how many of those you can write in on your own. I feel like a lot of you get to where I stopped and you stop because we don't use those double angles as much as the others, but they do kind of like to throw them in here on the FRQ. So usually people can try their best to remember sine of 2 theta. Does anybody remember it? Good. Okay, so for the double angle for cosine, just a reminder, if it's a sine or a cosine you write, it is squared, okay? And so one of those has both sine and cosine squared, but they are subtracted, cosine minus sine squared. All of these double angle cosine have subtraction. This one has a 1 minus 2 sine squared, and this has 2 cosine squared minus 1. And so these kind of stay in the same order. If this is sine squared, that's going to be subtracted. And the cosine squared won't be subtracted. Anyway, it's a lot to remember. However, you guys have over a week before this test. So even though a lot of you are not going to be in here with me because of different things, you still can study and remember these identities so you can get these questions right. So I'll repost the flashcards if you want me to. So you have time to really be ready. Now I know it's hard at the end of the year to stay focused, especially if you have other stuff going on, which most of you do. But I would hate for you to work so hard all year and here at the end just say, oh, whatever, I'm not going to try. So you're so close to getting this college credit. All right, so it's also possible that you'll have a trig equation. You will definitely have at least one of these, either a trig equation or an inverse trig equation. So for the trig equation, you're going to isolate the trig function, so get the tangent by itself or the sine or whatever. Then you're going to find an angle that gives you that trig ratio from the unit circle that you drew. So I would highly recommend that at some point during your test you draw a unit circle. I don't know if they're going to take your scrap paper away from you at this point. You might have to draw another one on your free response booklet. I'm not sure. I'll try to look at the directions and let you know. Anyway, so find that angle that gives you that trig ratio. And then if you're not given an interval of angles, so the interval of angles would be something like between 0 and 2 pi, or between 0 and pi. If you're not given that, then you're going to have to do plus 2n pi for sine, or plus 2n pi, plus n pi for tangent. So not given these things. Then you're going to write that. Why is it just pi n for tangent? You use the top half, and the period of tangent, the parent function tangent is 1 pi. The period of sine and cosine is 2 pi. All right. Then, if it's an inverse trig function, you're going to rewrite it using or rewrite it as a regular trig function. So if we have the arc sine of 2x is equal to the angle pi over 6, we can change it to regular sine of pi over 6 equals 2x. And then you're just going to do it like a regular trig. You're never going to do plus 2n pi or n pi on inverse trig functions because they have a very small range. So what is this sine of pi over 6? So you just change that to 1/2, and then you're going to divide by 2. So what's 1/2 divided by 2? Or half of 1? 1/4. There you go. All right, so let's practice some of these. All right, and I used, normally I use Brian Passwater. These questions, most of them were made up by David Hornbeck instead, but it doesn't matter. They're still really good questions. So make sure you find the one. It's hard to see, but it does say task model A, and the first one, G, it should be 10 to the 3x plus 2. So you have 2 on your desk. Make sure you're looking at the right one or it get confusing. Bless you. Okay, so directions for part 4 will always say the same things. This is verbatim what it's going to say. So one thing to keep in mind is you have to if it can be simplified, you have to simplify it. So for example, if you have log base 2 of 8, they expect you to tell what that equals. What does log base 2 of 8 equal? Yes, because you ask yourself 2 to what power gives you 8. So log base 2 of 8 is just 3. You will have to write that. That was very nice. All right, cosine of pi over 2, what is that?
0.
Yes, good. All right, then the inverse sine of 1. So it's like what angle gives you a sine of 1?
Pi over 2.
Yep. You guys are good. You got that unit circle down in your brain. I love it. All right, so Also, if you have something algebraic that you need to simplify, so just adding 2x and 3x, you need to actually add that. That's pretty easy. If you have 5 to the second times 5 to the third, what should that give you? 5 to the what? Fifth. They probably don't want you to find 5 to the fifth because that's a waste of time, and that would take forever. So just leave it, 5 to the fifth. All right. Also, if it's division, they would want you to go ahead and subtract those exponents. If you have two logarithms added to each other, what do you use to bring them together? Multiplication. They would want you to change that to the natural log of 15. So if you can do something without a calculator, then they want you to do it to simplify it. All right, they do assume that angles are in radians. Yeah. Okay, so here we go. So on part A, you'll be given a g and a h function, and then you're going to be asked to solve equations by setting it equal to certain numbers. So we want to, on part 1, we want to take the g function and we want to set it equal to 8. So that's what we're going to do. Right? This is an exponential function. If it was possible that we could do something to a power and then that same thing to a power and get 10 and 8, then that would be the easiest way to do it, to write them with the same base. Excuse me, but that's not possible with 10 and 8. So in this case, we're going to do the loop. We're going to change this to logarithmic form. So it's going to be log base 10 of 8 is equal to 3x plus 2. Now, is it possible without a calculator for us to figure out what log base 10 of 8 is? No, then they don't expect you to. Also, with a base 10, you technically don't have to write a base. It's not wrong if you do, but you don't have to. So we just need to do whatever we need to do algebraically to solve this for x. So what would you all do first? Yep. Now, it's not necessary for you to put these parentheses around the 8, but I feel like, especially if you're subtracting something, that you need those parentheses. So the person grading your test will know that you know you're not actually going to subtract them. And then just divide by 3. And so x is going to be this super weird fraction, but that's fine. And that's it. Okay, and then make sure that you go down, when we finish that question, we're going to do the second part of A, that you go down and write it in that part. They will grade, if you write it up here, they are going to grade it, it's fine, but I'm just worried if we don't fill this space, when you go to do the next one, you're going to do it here, and I don't know if they will grade it. They'll grade part B in all of this, but I'm not sure if they'll grade part B over here. So just be careful. Just write it where it tells you to write it. All right, so part A, part 2, we're going to take the h and we're going to set it equal to pi over 3. And we're going to find all the x values in the domain of h that is the case. So this is kind of like on your notes, the very last thing we did. It's just a little bit more challenging. So before I can write this as cosine, I need to get rid of that 2. And so I would just divide by that 2. And what is pi over 3 divided by 2? Yep. So dividing by 2 and multiplying by 1/2, same thing. Okay, so now I can write this as a cosine equation where the cosine of pi over 6 is equal to x over 3. So it is the cosine of pi over 6. What happened to what? X over 2? Oh. Thank you. Those all should be x over 2s, not x over 3s. Can you guys just look at that and tell what x is? What's x? Square root of 3. So if square root of 3 over 2 is equal to x over 2, and then x is the square root of 3, if it's a more difficult challenge, or if it's a more difficult question, you would just multiply by 2, and you would still get square root of 3, however you need to do it. All right, y'all, okay? Okay, let's look at the next one. So now we have J and K, and these are going to be to rewrite as equivalent expressions. So J is a logarithmic that we want to write it as a single logarithm, and the form should be the natural log of just an expression. So what I'm going to do for this one is rewrite it with an exponent. So what exponent means square root? Yes, thank you. So we can rewrite the square root of x as x to the 1/2. And then what am I going to do with this 2 if I'm using properties of logarithms? Where would it move? To an exponent. Good. Okay, so let's do that. Right, and then what do you do when you have a power raised to another power? What do you do with them? You multiply them. So you can rewrite this as minus natural log of x to the 6. Okay, and then we have 2 logarithms separated by subtraction. We're going to bring them together using division. Now, if at this point this was like x to the 1/2 and y to the 6, you would be done. But this is definitely one of the more challenging ones where we are actually going to need to simplify this. And when we do simplify it, we can have, it says without negative exponents. So this is kind of the same idea that we had here where we subtracted, but this is actually more difficult for a couple of reasons. For one, when we subtract, if we have x to the 1/2 on the top and x to the 6 in the denominator, where are your x's going to be left over when you simplify that?
The bottom.
Why? You're right. Why on the bottom? Because there's more, yes. So we're not going to subtract. We're not just going to subtract top minus bottom. We're going to subtract bigger exponent minus smaller exponent. Can you guys subtract 1/2 from 6?
Yes.
Whoops. How many halves is 6?
12.
Good. Okay, so I know I'm going to have my x's just in the denominator, and when I subtract, 12 halves minus 1/2 is going to be 11 halves. Now there's a good chance this question is not going to be this challenging on your test, where you have to know that 1/2 means the square root, exponent of 1/2 means the square root. You're going to have to subtract fractions, and that x is going to go in the denominator. There's a good chance you won't have to know that, but you're definitely going to need to know the properties of logarithms, and you're definitely going to need to know to subtract those. Or it might be just this challenging. You never know. Okay, for part B, we have k, and we want to write this as an expression involving sine of x and no other trig functions. All right, so it is secant of x times sine squared times cotangent of x. So what do we usually do when it's all multiplication? What kind of fractions? Fractions involving what? Only sine and cosine. That typically helps you get to the answer. So let's do that. For secant of x, we'll change it to 1 over cosine of x. Sine squared, we're going to leave alone. leave it like it is. I'm going to put it over 1. You don't have to if you don't want to. It's okay. That's not right or wrong. All right, and then for cotangent of x, we're going to change it to cosine of x over sine of x. All right, since this is all multiplication, anything in the denominator can cancel out of the numerator if they're in both places. Sorry, I'm having a hard time saying words. All right, so this cosine of x in this denominator will cancel cosine of x out of the other numerator. And then one of these signs will be canceled also. So what are you left with? Sine of x. Good job. Now I know that sometimes you know what the answer is going to be by the way the question is worded, especially on the other one we're going to do on the next paper. So if you just say that this answer is sine of x because you know it's an expression involving sine of x and no other, you won't get credit. Your work has to support your answer. So this is one where it's crazy important that you show every single step. There's not a lot on this one, but just be careful. You have to prove to them that you are as smart as you are. All right, and then part C. This one will be a 2-point question for this box. It's usually an equation that involves a lot more things. So with this time M, we want to find all of the values in the domain of M that yield an output of 2. So that means we're going to take it and we're going to set it equal to 2. So this is a trigonometric equation where the first thing we want to do is isolate the trigonometric ratio. We want to get tangent alone by dividing this 2 over the square root of 3. I'm sorry, 2 times the square root of 3. All right, and so that would simplify down to 1 over the square root of 3. I'm going to draw a couple of angles on the unit circle that have the square root of 3 in one of the coordinates. So for this one, that's pi over 6, I moved over more than I moved up. So that would mean the square root of 3 over 2 is my x, and 1/2 is my y. And then just the opposite on the other one, I moved up more than I moved over. Okay, so that's a small little portion of the unit circle that I need you all to see so I can talk about it. All right, so if I do a tangent from the unit circle, what do I do? Sine over cosine or y over x. Both of those are 100% true. And so I want to be able to do a y divided by an x, and I end up with 1 over the square root of 3. And so if you notice, the square root of 3's on your unit circle are in the numerator. But when I do y over x, the square root of 3 is in the denominator. So which one of those, the y or the x, needs to have the square root of 3? Say it again. For it to get into the denominator, which one? The x. So the answer is going to be the pi over 6. That's the thought process I go through with tangent. Tangent's definitely the more challenging out of the 3 that you have to do. We're not done with this. Hold on. I'm going to let you guys get that written down and soak that in for a second. So were we given an interval of angles on this one to give? We weren't. So that means that for tangent, I'm also going to have to add in pi. We're given all the answers in the domain, which is going to be an infinite number of answers. Now, if it had been sine or cosine, there would have been 2 angles, probably, that I would have to give, and I would add 2 in pi. Okay, so we're not done. We also need to just solve this for x by subtracting pi over 4. Okay, so if I'm going to subtract pi over 6 minus pi over 4, what is my common denominator? 12. So 6 needs to get multiplied by 2. And 4 needs to get multiplied by 3. So x is going to be negative pi over 12 plus n pi. All right, are y'all okay? It's a lot. Some people are shaking their head now. So you have to know how to solve trig, but you also have to know how to subtract fractions. And remember that you have to do the plus in pi. So this is a 2-part question. I feel like you get 1 point for this and 1 point for remembering that, but I'm not 100% sure. Okay, let's look at the other FRQ. All of these questions are going to be different. So there's just so many things I can put on here. I wanted you to see some of all of it before you did it on your own. Okay, so this one, G, is 3 plus 4 sine of x. And we want to find when that is equal to negative 1. And then it says in the interval from 0 to 2 pi. So when you see that, for just a regular sine, you do not add 2 pi in. You just give the answer. Okay, so let's take it. 3 plus 4 sine of x and set it equal to negative 1. Oh no, this is where I did this in my other class. There we go. Okay, so let's take it and set it equal to negative 1. All right, you guys take a second and you get sine of x by itself on your own. This was a kind of a weird situation where it still equals negative 1 even when you get the sine of x by itself, but it's fine. Okay, so let's think about the unit circle or the graph of sine, whichever way you want to think about it. But what angle gives a sine that is negative 1? 3 pi over 2. So if we're thinking about the unit circle, for 1 or negative 1 is going to be one of the quadrant angles. And we're looking for a quadrant angle where the y is negative 1. What about tangent? When is tangent equal to 1 or negative 1? The pi over 4 angles. Those are the ones that have a slope of 1 or a slope of negative 1. Nice job. But that's it. I hope you get one like this, actually. It's not too terrible. All right, and then for part 2, we want to know when h is equal to 3. So let's take h. And set it equal to 3. Okay, so there's 2 types. Is when we have log equals a number and when we have log equals log. So this is eventually going to be log equals a number. But right now it's log plus log equals a number. So we need to bring those together as one logarithm. So what are we going to use? Multiplication. Right, then when it is finally log equals a number, you're going to do the loop, if that's the way you like to think of it, or you're going to write it in exponential form. Either way, you're going to get that 8 is equal to x squared minus 2x. Okay. Whenever you're solving, now we're solving a quadratic equation. And so when you have an x squared and an x, and you're solving a quadratic equation, do you guys remember how we're going to solve it? You're going to get everything on one side, and you're going to factor it. And this quadratic equation has 2 answers. That does not mean the logarithmic equation has two answers. Most logarithmic equations don't have two answers. They can, but most of them don't. So, what is the rule about the argument of a logarithm? Can't be negative, also can't be 0. So the argument has to be greater than 0. So if I plug -2 into either one of these, it fails. And so it's -2 is an extraneous solution, so you're just going to need to mark it out. Don't box the other answer. I don't want you boxing, but just mark out the -2. If I put 4 in, it's fine. I get 2 positive arguments on that. Okay, sorry, we got to move faster than I'm moving. All right, part B. I love these questions, and we practiced it. We just haven't done it in a really long time. And so what we want is for this expression here, J, to be written as 2 to some power. So what do I want to write the 8 and the 4 as? What bases? 2's. So how can I write 8 as 2 to power? Yes, sir. So 2 to the power of 3. And there was already a power on that. So we can raise that whole thing to the x. And then 2 is going to stay what it is. And then what about 4? 2 to the second. All right, and then we've already talked about this once today. When you have a power raised to a power, you are going to multiply those. All right, and then we're ready. We're going to have 2 raised to a power. And then if the powers are on the numerator, you're going to add those together. What about the denominator? We're going to subtract. Okay. B part 2 is pretty tough, but we can do it. There's lots of ways we can get to the answer, but we want to write this as a product of secant of x and cosecant of x. So this is another one, and I put one, it might have been this one like this on the test, and a whole lot of people did some work, and then they wrote that the answer was a product of secant and cosecant. But if your work doesn't support this answer, even if it's the right answer, you won't get credit. So let's do all the work. So what I'm going to do first is just rewrite this as tangent of x plus, and then I'm going to write cotangent as 1 over tangent of x. Now, we could do sine and cosine, and it would still work out fine. But I'm going to do it this way. So if I'm going to add these together, I need a common denominator, and it is going to be tangent of x. And then once I have a common denominator, I can make one fraction with the common denominator as the denominator. And the numerator, I'll just do all the things. So I'll multiply tangent of x by itself, and then add 1. Does that ring a bell? Tangent squared of x plus 1, what is that going to be? Good. But we're still not ready. We need to eventually just have secant of x and cosecant of x. So we're going to do our favorite thing to do and rewrite these as sine and cosine only. And that looks way worse. But once I get it like this, I know that I can multiply by the reciprocal of the denominator. And now a cosine will cancel out, and we're very close to the answer. All right, so once I get to this, then I can tell the people I know that is secant of x times cosecant of x. Which you might have known from the beginning that that's what it was going to look like, but you have to show all the things. So I get all the things, please. Okay, And then the very last one, we are going to set that m equal to -9. Now, believe it or not, this is very, very much like this. We're going to do the exact same things, but we don't have x squared. We have 3 to the x squared. And we don't have x here. We have 3 to the x. But we are literally going to do the same exact thing. We are going to get everything on one side. And then we're going to factor it. But because I don't want x squared, I want 3 to the x squared. This has to be 3 to the x and 3 to the x. I know that's weird, but we can do it. We can do hard things and we can do weird things. All right, so, and then I know that this tells me my signs are the same and they're both minuses. And then I want to multiply to get 9 and add to get 10. What multiplies to get 9 and adds to get 10? 9 and 1. Everyone forgets about 9 and 1. Okay, so then I have 3 to the x minus 9 is 0. And I have that 3 to the x minus 1 is 0. So 3 to the x is going to be 9. What does x need to be? 2. And 3 to the x is going to be 1. What does x need to be? Yes. So everything except 0 to the 0 power is 1.